Algebra 2, Lesson 64, complex numbers, or I'm sorry, complex fractions and complex numbers. We'll start with complex fractions, because these are rules we already know. So, for complex fractions, we're just combining abstract fractions with our rules of inverting and multiplying, and then also our rules of adding fractions. So, when we see this complex fraction right here, remember we have to start from the smallest fraction and work our way up. The smallest fraction is always the one with the shortest line or the thinnest line. So I believe in your book they just darken the actual middle line of whatever fractions you're dealing with. So we're going to start in this denominator right here. Now before I can invert and multiply this denominator, I realize that this is a polynomial. Again, there's a plus or a minus sign. Plus or minus signs make your work a little bit harder. So before I can invert and multiply, I have to write this as a single fraction. So I have to turn this 1 into a number that has the same common denominator. So I'll multiply 1 by x over x, which turns this problem into, my focus is a little blurry. Let's see if I can clean this up. There we go. When I multiply, it turns this problem into x over x plus b over x. And I can write this as a single fraction as x plus b all over x. Now all of that is underneath 4, so we're going to take this denominator and we're going to invert and multiply. So that becomes 4 over 1 times x over x plus b. When I multiply, that gives me 4x over x plus b. Now I'm not done, because remember I still have a over x, right? So I've simplified this whole piece right here, but I still have a over x plus 4x over x plus b. Again, we go back to our rules of adding fractions. I need a common denominator. In this case, the common denominator is going to be x times parentheses x plus b. So I'll go ahead and multiply by the missing pieces over here. Multiply by x plus b over x plus b. And here I'm going to multiply by x over x, our different values of 1. And so, again, same thing that we did here. Once I get the common denominator, I can just write the numerator as a polynomial over the single denominator. So when I multiply this one, I don't forget that I have to use distributive property. That gives me ax plus bx, or I'm sorry, ba, or ab. Ax plus ab is what I get when I use distributive property here over x times parentheses x plus b. And then that's going to be added to this, which becomes 4x squared over x parentheses x plus b. And then just like the first problem, I'll take both of these and write them as a single numerator over the common denominator. So my final answer is going to be ax plus ab. I just realized I wrote that as a d, not a b. Plus ab plus 4x squared. And that's my final answer. Some of you may be asking, do I have to distribute here? The answer is no. You could write this final answer as a times parentheses x plus b and parentheses plus 4x squared all over x parentheses x plus b. And then the other question is, well, can I distribute down here? Yes, you can. Another way to write the answer would be to write all of this over the denominator x squared plus bx. So these two are the same number. These two are the same number. And then, as we're checking our homework, if you have questions on that, just let me know, and I'll tell you whether or not your answer is or isn't correct. Now we move on to complex numbers. We're going to spend a good amount of time talking about complex numbers in class, because they're a tough thing to tackle. The short version is, the complex number that we're referring to is the number I, as you see right here. And the number I is equal to the square root of -1. Right? And then when you run into numbers like I squared, that's just equal to -1. And the reason why is because the square root of -1 times the square root of -1 just gives you -1. And then if we run into I cubed, that gives us -1 times the square root of -1. And then I to the power of 4 just comes out to be positive 1. We should be talking about that pretty heavily in class, so if you need a refresher on that, you can always talk to me, but this is the main chart that you need to remember. Odd numbers either leave an I or make the number negative. Even numbers give you a whole -1, and we have to go to 4 on this because you need 4 to complete the cycle to go all the way from 1i to positive 1. That's all I'm going to talk about that on the video. Let's talk about how this affects our problems. So let's go to an example problem. And the reason why we use I is because we can't have the square root of a negative number, so we usually have to pull it off to the side to avoid having to deal with it. So the example problems that they give us, let's see here, we've got 4i cubed minus 2i to the power of 4 plus 2 times the square root of -9 plus square root of -3 times the square root of -3. Now, we have to be careful when we get to these negative square roots because some people might try to simplify this one in the wrong manner. But we'll start with 4i cubed. Remember, I cubed comes out to -1 times the square root of -1. So I cubed times 4 would give us -4 times the square root of -1. Here we have minus 2i to the power of 4. I to the power of 4 gives us positive 1. So we'll go ahead and write that as just -2 because 2 times 1 is just 2. So we have -2. That one doesn't really change. Now here, this negative radical, that's where it gets tricky. We have to rewrite square root of 9, or square root of -9 is square root of 9 times I. And the reason why is because square root of -9 can factor into 9 and -1. And these are technically both under square roots. So we're separating it, and then we're rewriting that negative square root as the number I. So this becomes 2 times the square root of 9i. Square root of 9 is 3. So 2 times 3i gives us 6i. So then we have plus 6i. Now this last one, some of you may want to simplify this and just make it -3. That may work. Sometimes it may not work. Other times, I'm just going to tell you, every time you see a negative radical, always turn it into a complex number first by putting the I next to it. So I'm going to rewrite this as square root of 3i times square root of 3i. The 3's become 1 whole 3, so that just becomes plus 3, and then I squared is -1. So 3 times -1 gives me -3. So come back over here. Oh, and then this 4, -4 times the square root of -1. This one I should turn back into an I. I forgot to finish that one. So this first term we have -4i minus 2 plus 6i minus 3. From here, all we have to do is just add like terms. So -4i plus 6i gives me positive 2i. -2 minus 3 gives me -5, or -2 plus -3. And my answer is -5 plus 2i. And yes, we always write the whole number, then the complex number. It's just a proper ordering that helps everyone see things in the same way. If you have any questions, let me know on Moodle, and I will see you in class.